Hello and welcome back. In this video, we will take a look at the relationships that UML class diagram talks about. At a very high level, there are four types of relationships within a class diagram or between various entities in a class diagram, and they are association, aggregation, generalization, and realization. Association itself and aggregation also actually has two subtypes, so to speak. So we'll talk about all of them in the next video. But in this one, let's take a look at generalization and realization. So let's start with the concept of generalization. In terms of object-oriented principles, generalization refers to the inheritance principle. So if I have a class called, let's call it base class for now, and I could have a child class or a subclass, and we basically are trying to say this child class extends this particular base class. So the symbol that we use in terms of UML is generalization. So I'm going to click on generalization. I'm going to start from the child class and take it to the base class. So basically saying this particular child class extends this base class. So please note the notation is it's a rectangle with a solid line, and the rectangle happens to be on the side of the base class, right? So that's the notation itself. Now, if I were to draw this and I say this is some kind of base class 2 or 3, some other class that's other than the base class, and if I ask you a question, can I actually draw this? Is this valid? What's your answer going to be? So the two answers that you could have given me is you could have asked the question, what is the language that we are going to consider when we draw this particular diagram? You could have asked me that particular question. Or the second one would be say, yes, this is valid in terms of UML, but may or may not be valid given a particular language. So this is the other thing that I was referring to while I was talking in the previous section about how to consider the constraints of a given language before we draw class and sequence diagram. Now, as you notice, if you were to consider C++ as our choice of language, this is very much valid because C++ does allow us to have multiple inheritance model, whereas it may not be the case when it comes to either Java or .NET or some other language. So it's very important to consider the the language constructs, and consider the restrictions that the language places on the modeling itself. And based on that, you can actually say whether it's valid or not. So just from a UML standpoint of view, it's very much valid because UML can be used to model any OOP language, but given the constraints of a specific language, this may or may not be valid. So that's the way to look at it, and that's the way to answer that particular question. So generalization is about class extending other classes. Now let's move on to the next one, realization. Realization refers to a class implementing one or more interfaces. So let me draw that first. I could actually have a class. I'm just going to leave it as class 1 for now, and I'm going to add an interface, and I'll leave it as interface for now, and add another interface called interface 2, and the symbol that we're going to now use, or the UML notation that we now need to use, is realization. Again, like we did last time around, we got to start from class 1 and going to take it towards interface 1, and similarly towards interface 2. And if you notice, in terms of symbol, it is still a triangle, but now it is a dotted line. And given that most of the languages do support multiple interface approach, this is obviously very applicable in terms of most of the languages that we use on a day-to-day basis. But you still need to consider the constraints of the language and then decide. But from a UML standpoint of view, given that it's not meant for a specific language or language, this obviously is very much applicable. So generalization refers to extension or inheritance based approach, whereas interfaces talk about a class implementing a given interface. So I'll just clean this up just to put the rectangle like I did last time around, and that's where I'm actually going to end this video. So here are the two polished diagrams of generalization and realization. I just cleaned them up a bit, organized them so that I can keep all these diagrams on the same page, so to speak. and I'll make this, I'll export this diagram as JPEGs and put it up on as part of the course material as well, so that you guys can refer to it whenever you need. So we've talked about generalization and realization. In the next video, we're going to start looking at association and aggregation. I'll see you guys later.